So hello everyone. Thank you for inviting me to this. This is a presentation that we were invited to give at the IW 4 years ago. And so we put this together to explain how we were implementing model-based systems engineering at the Boeing company. So some of the co-authors are still working there and working on MBSE. Robert Malone and John Palmer are still there. Barbara Sheely and I have both retired since this was done. So I'm going to cover these 4 topics just to let you know what Boeing does and how we approached MBSE given what we do or what Boeing does. I can't really say we anymore. Challenges we noted and some specific needs that we identified for people who are developing MBSE capability. And not very much in here is exclusive to what Boeing talks about with respect to what other companies might need or talk about, but this was our perspective in addressing the request from INCOSE for this presentation. So Boeing is a large company. These are 2012 numbers, so they're probably a lot bigger in some cases in terms of annual sales. The company operates in many countries. The company sells commercial airplanes mostly outside the United States and has a robust defense and space business primarily centered in the U.S. This is a company that has grown out of mergers of many aerospace companies over the years: McDonnell, Douglas, Hughes Helicopters, Hughes Space and Communication, Vertol, as well as Boeing commercial airplanes growing up in the Seattle area. The products range from military airplanes, commercial airplanes, satellites, networks, cargo airplanes, vertical lift, helicopters, and so forth. And the challenge of all this is how do you come up with an approach and capability to implement model-based systems engineering that everybody can live with. Wouldn't say happy with necessarily, but at least everybody can live with it. And that's a challenge, even across, for example, different commercial airplane models. Every program has their own preferences. And so every project has to, in a sense, readopt whatever approach to processes and methods. So the company's organized in commercial airplanes and aviation services, and then defense, space, and security had 4 divisions within it, as indicated. And the company designs and builds everything from components to systems of systems, and things that are highly networked are now pretty standard. And generally, these systems operate with very high performance demands. So figuring out how to yield better performance given strengths of weight and power and size and so forth. So the different product lines yield a need for MBSE solutions that can adapt to those. So let me tell you what we did. One of the first things we found was that we had to re-educate people on what systems engineering was, because for many folks since the 1990s, system engineering had come to mean requirements management. And we know it's a lot more than that, but not everybody who wasn't a systems engineer knew that. So explaining, part of selling the idea of MBSE was in part selling the idea of systems engineering. So the emphasis was on training and training courses and process definition and emphasizing the importance of functional models as a basis for being able to implement systems engineering, whether in a model-based environment or otherwise. once we can educate, then of course we have to have the MBSE capability, and it's not just enough to have the tools. It's about explaining how to use it, showing how to use it, coming alongside, demonstrating it. We established a core group to provide support for all programs. So this was a well-funded overhead function that would go out to provide training and introduction and capability definition for programs that were interested. And the deployment, sometimes we had small clusters of people within programs, and every once in a while a major program would adopt MBSE, and then it was a matter of training hundreds of people who were involved in this. Nothing succeeds like success, and so providing a means to capture lessons learned and successes and share them with the faint of heart became very important in keeping this idea of deploying MBSE, if you will, sold to those who were not yet convinced of the value to their project. So we recognized, since this was a funded activity at the corporate level, we had to provide a corporate or enterprise approach. So we had to come up with a set of common processes and a set of common tools that everyone could use. And even though every division talks about doing systems engineering, every division uses systems engineering slightly differently. So the processes, when you get down to the details, end up being slightly different, which means the tools have to be adapted or have to be adaptable into those process variations. But we settled on a process architecture with the tool support behind it that addressed the idea of requirements architecture, functional architecture, logical architecture as a way of instantiating what we were doing in systems engineering. And we eventually extended the data in the data model into the integration, verification, and validation activities to close up the V-chart. We established a corporate program or project called Integrated Product Architectures, and that was led by, for a number of years, by Barbara Shealy before she retired, and I got invited to join this. And I was, among other things I did, I became the process architect, so I was responsible for capturing in the requirements for the tools we were building and tailoring from the various divisional processes and trying to keep all the divisions happy with what we were doing. This was more or less successful because the tool implements the processes, but we had to address lots of different needs with different prioritizations. Certainly people wanted to be able to maintain their requirements management capabilities based on other tools, but we wanted, obviously, to go beyond that. Some programs wanted DODAP views, some didn't. Some people wanted verification logic networks. Everybody needed the basic functional behavior in order to support the development of their requirements, but not everybody understood how to develop that and use that. And a capability we developed shortly before I retired a few years ago was generating interface control documentation from the model as well. Keep remembering to click the arrow up at the top here to advance the slide. So this was an animated slide, so let me just talk to it from left to right. We start with requirements. From where they come, we have to identify the stakeholders, what they care about, what their measures of success are, what their concept of operations and concept of maintenance, and capture all that, and then build models of that along the way to be sure that those things are going to be right and consistent. And so along the way, and this was a theme of the various MBSE workshops over the years at the IW, simulating the system or portions thereof as a prelude to actually having it built in order to confirm that the models of what you're making actually work, and therefore what you're making should be correct or valid, if you will. So first thing is figure out that we have the right requirements and that we have the right interfaces that allow the exchange of information and energy and so forth, the definition of the components and the logical architecture that have the right interfaces, that implement the right requirements, and collectively then, when we have these things with the right behavior, we should end up with something that is closer to the right system than we are otherwise able to have with just a document-based system, where really the proof of the pudding becomes when it's built and you're beginning verification, which is way too late for managing risk effectively. So having a tool that allows us to exercise elements of the models in a simulation is really critical for helping us ensure that we get it right the first time. And the transformation from requirements that are stated in words, so this is an example from one of the commercial airplane programs, to control airspeed, to transmit the airspeed. What are the functions that we need, and then how are those realized in elements of the logical architecture? And the MBSE database allows you to connect these things together so that if something changes, you can understand what the impacts are, or if something isn't working properly, you can trace back to what the impact is on either satisfying the requirements or having to revise the implementation and the logical architecture. What we finally settled on in our tool suite as of early 2014 for what I call classical or structured MBSE approach, SADT, we were using a customization of the Siemens Team Center for Systems Engineering. That has since gone by the by as far as Siemens is concerned. They're no longer developing that. We had planned to transition to Team Center Unified, but found that it did not have the capabilities that were needed for the future tools. So I know the Boeing company has embarked on another set of tools, and I don't know exactly what they are at this point. For those who were interested in object-oriented approaches and wanted to use SysML or in software-dominated projects, we adopted the company standard for UML as the SysML tool of choice. So every program got to choose. Did they want to use a SysML approach or a structured modeling approach with emphasis on functions and functional behavior and control and data flows and so forth, for those of us who are more classically trained in systems engineering. So we had both of these tool options, and we had training to support both of them. And one of the first things we would do in consulting with a program is to understand what they thought they needed and make a recommendation as to which path they were going to go down. And some projects even included elements of both of these. The biggest challenge, of course, is deploying the capability, how to get a new thing adopted. And I paid attention to some comments that Eric Herzog made back in 2010 about, for legacy programs, of applying the MBSE to the increment or the change so that you don't have to redo everything on an existing project, but you begin introducing it when you have something new to do. And many programs in the Boeing company are of this kind, where we've been developing and supporting certain airplanes and other systems for decades. But change is a reality, so trying to promote the idea of let's do this next change using MBSE. And so the programs would want to know, well, how's that going to affect us? What's it going to cost? are you going to teach us? Are you going to provide us the tools? And so we adopted this tell, show, do, apply learning methodology, which is pretty standard in educational environments, to come alongside the program to train them in not just the tools, but the processes, and remind them that systems engineering is more than requirements management. So that's how we addressed legacy programs. For new programs, it's critical to gain visibility and adoption even before the proposal activities start. Because once a project is into a proposal activity, you're almost too late to change somebody's mind about the processes and tools they're going to use. So this ends up being extremely important and requires a lot of effort to know what projects are about to start up and gain a hearing, and then provide all that they're asking for during the proposal or program definition phase in terms of training and expertise and the tools and setting up databases and servers and all of that that goes on with this. And that was one of the reasons we had a core group at the corporate level, so that we could assign half a dozen people full-time effectively to the project to get it going. But we have to worry about what happens when those half a dozen people are withdrawn, to make sure that the new way of doing things gets embedded in the organizational culture. So we would have continuous follow-up to work with the programs to make sure that they are not running into roadblocks and they're not in danger of abandoning the new way of doing things. So it does become very labor intensive on the part of the overhead organization to make sure that the MBSE methodology is actually going to persist after the experts are no longer the primary ones doing the work on the program. Challenges. So here are 7 or 8 challenges, and I'll go through these one at a time. Legacy and new products, process definition, transition to downstream lifecycle phases and other tools, product complexity, the quantity of engineering data. I've got a slide that people love to take pictures of. Process tool training and skills, and the use of diagramming and some of the limitations of that. So this is a fairly old slide that represents where we were getting to in terms of complexity and software size, going from what they call legacy programs to the last one for which we had data, the 787. And even now, this is probably 8 or 10 years old. Since the 787 rolled out in the 2007-2008 timeframe. So things continue to grow, and I know, being at INCOSE a few times, BMW has their own slides that say, they're growing even faster in terms of lines of code, and that's fine. The message is things get bigger and things get more complex, and there's more interaction. So whatever MBSE tools we're trying to promote have to be able to handle this situation. For one of the airplane programs, this was the quantity of data that we were dealing with, and about 14 gigabytes of data and 60 million objects in the database. And what we found was most of the MBSE tools we investigated had a hard time scaling to this volume. And that's one of the real problems, is there is so much data, and you can imagine if you're trying to run reports, generate diagrams with this much data, it can be very challenging on both the software as well as the hardware. And if you've got hundreds of users in the system, you have to pay attention to synchronization and read and write and modify writes, and who's got access to what portions of the data, and how do you handle supplier proprietary information to make sure it is properly protected? How do you handle export controls and so forth? So database management is a very big challenge, not just from the standpoint of quantitative engineering, but all the other things that go along with it. The training and skill challenges, we identified 4 areas where we really needed knowledge to be effective in applying MBSE. One is simply system engineering knowledge and experience. A lot of people, as I've said a couple of times, many people thought SE was just requirements management because those are the tools they had. So trying to remind people or introduce people to the other elements of systems engineering became a critical skill. Understanding of the product domain they are working in so they could understand what are the important characteristics, what really matters, what has to be defined, where are the interfaces going to be, how are you going to analyze for performance, and so forth. Tool user skills, no matter what tool you adopt, you're going to have to train people in the use of it, and every tool has its own idiosyncrasies. Anyway, things that you have to get around that people may not like, and you may not be able to fix it. The last one we identified was just the ability to do modeling. In fact, and I'm doing a presentation tomorrow evening for the Chicago chapter on system engineering modeling skills in general, at their request. After they saw this presentation, they asked for this. So that's tomorrow afternoon for Chicago. But this ended up being one of the most difficult things, to understand and know at what model to build, at what level of detail, based on what questions you're trying to answer, what you're going to do with the information you put in the model. This used to be a basic part of systems engineering, and it seems to have sort of withered away in the grand population, so that it now becomes a skill that has to be retrained. And so that's something we just had to do. And this was mainly done through workshops with the programs where we would actually do the modeling real time with the program, because they're the ones that know their products, and introduce them to using the tools, and then what to capture in the model. And even if someone is trained in the tool and believes they have an understanding of systems engineering, they may not be an effective modeler right off the bat. The tendency, of course, is to model everything I think I know. And what that leads to is a vast amount of unnecessary detail and eventual rework every time something changes. So restraining the tendency to model everything you think you know, and focus on modeling the things that are necessary to answer the questions that are in front of us. And this is something that in part has to be learned by experience and mentoring and on-the-job training. Diagramming is one of the reasons we do MBSE, because humans interact with diagrams better than tables. We can more easily understand connections. On the other hand, when these systems get complex, the diagrams become so complex that they're almost no longer usable for their intended purpose. So we had to establish other methods for managing the information and ensuring that it's correct. So import utilities, spreadsheet reports, document reports, reports on connections among things in the database that you can scan and analyze, not simply looking at a diagram to see that, yes, the lines line up where they're supposed to, and so forth. And when you've got millions of objects diagrams become so complex that, first of all, they take a long time for the tools to build and present, and in the second place, then they're very difficult to inspect to determine if they're correct or not. So we needed reporting capabilities out of the various tools to make sure that even when the diagrams became too complex, we could still be confident that the information was correct. Which leads us into our, what did we need? So I'm not sure how far along we are in all of these topics. Several people, Matthew House was one of them, who also talked about the need for success stories to help promote the benefits of MBSE. Another one was methods to measure the impact. Can't remember the gentleman's name from John Deere at IW or INCOSE a few years ago said, you know, realistically, the first adopter of an MBSE tool and process is going to be a net cost. It's the following programs that will realize the benefit. And when your cost centers are program-based, that is a very, very difficult sell to a project when you say, yeah, this might cost you more than doing it the old way, but it'll make the next thing go so much better. And trying to find leaders who understand the vision of, I've got to help the enterprise over the long term, and I'm willing to invest in this new capability so that those who follow gain the benefit. Those leaders tend to be few and far between for the obvious financial impact reasons. So this is a hard thing. Other ways to measure the impact of MBSE, how long does it take to process changes? How long does it take, in terms of effort and schedule for both of these, how long does it take to create a modified architecture for a different application or a different customer? Those become selling points because those kinds of things will tend to happen under the same program. And when you see that adopting this methodology can save you time because of the ease with which you can make the modifications, then that becomes a selling point. But being able to measure the impact in a way that's useful for project managers to appreciate the benefits was a challenge. I've already talked about the challenge of being able to train good modelers. And this is something I think that happens over the course of months and years, but people have to be familiar with all the other elements. What is good systems engineering? How does this tool work? What are the essential elements of the product domain I'm trying to model? And then we can go make the models. And then organizational behavior and psychology. How to ensure that the organization continues with the new process and tool and doesn't just simply abandon it. Because I have seen, and probably others have as well, once the expert moves away, then people go back to the old way of doing things. And I actually saw that on a number of programs. There was regression in terms of the quality of the work after the experts moved on. And I don't have a good answer for that, and my graduate degree is not in psychology. So we would certainly be open to people who have solutions to that problem. Tools are always going to be a challenge, and everybody has different things they complain about. We would, of course, want very powerful tools that have low user entry barriers. Somehow they can be more intuitive so it's obvious what to do. That's a goal. I don't know how realistic. We do need tools that can support hundreds of globally distributed users. And I think a lot of the MBSE tools recognize that there is a need for distributed collaboration. The size scaling continues to be a challenge, and this is a database issue as well as the MBSE tool itself Can it handle millions of objects? Can we instantiate everything in the diagram as a database object so we can assign properties to it? Not every tool handles all diagram objects this way. Some are just relationships that are established, and we don't have the means to assign specific kinds of properties. How to exchange information with the other disciplines. System engineering might like to think of itself as the center of the universe, but so does every other discipline. And it gets even worse once you get into manufacturing and product lifecycle management. So we know there are standards out there that should allow the exchange of systems engineering information, and it's probably incumbent on the customers to demand that those actually be implemented in work so that the tool providers implement those standards and we can actually exchange information. But I understand the incentive is to not enable tools to work together, because once I get a company or a project to buy my tool, if they don't have other options, then they're going to continue to stay with that tool if they can't export their data and so forth. So I understand some of the influences there, but the ability to exchange information with the other engineering disciplines or transition the information to downstream lifecycle phases, to transition the information into the verification activity is really important. Otherwise, the MBSE model just looks like a way to do requirements. Although they're going to be better requirements, they'll be well-founded requirements, but at the end of the day, you're going to have requirements because you can't link to the other kinds of data. Reuse of data in reference libraries, in models that can be put into libraries is very important and useful. That, of course, is one of the reasons we try and define objects with their various properties so that they can be reused. And we found that this is inherently a challenge. If you include all the interactions associated with the object, every time you want to reuse it, you include all those interfaces and exchanges. So the ability to do that is important, and we understand it's hard. Configuration and version control of all objects is really important. Being able to establish a baseline, be able to make modifications that may not be global because they're only going to be applied to certain certain variations of the product. Be able to place things under configuration control and know that you have a firm baseline. And this goes along with user security and access permissions and who is authorized to make changes and establish baselines and so forth. And then the ability to import and export lots of data and make updates by not just working through the user interface of the tool, but we made extensive use of imports using spreadsheets to update lots of data very quickly. And that's important when you're making global changes. And I think with that, I'm to my summary. So our challenges were we had diverse product lines, different customers, different legacy programs, new programs, different levels of skill, different levels of systems engineering, knowledge and skill, and different modeling capability. So all these things had to be addressed as we tried to establish and implement model-based systems engineering. We did have success. Some programs simply would not have been possible without this, and there have been other papers that perhaps have seen in INCOSE that talk about some of this. Could not do it given the volume of data and the level of interaction of the various networks and computer systems. Just trying to keep track of everything would simply not be possible in a paper-based system. So Boeing's committed to moving forward. They're continuing to move forward with it. I say Boeing is going into a next generation set of tools for the next programs. I don't know what that is. You'd have to talk with somebody at Boeing about that, but MBSE has been established and it will continue to be further deployed at the Boeing company. And we need help from others in industry in figuring out how to exchange data among the different tools, because everybody does it just a little differently. So with that, I will hand it back over to Rick Dove. Thanks very much.